Hi, what's up people? Mr. Highway here. Today I received a text from some students asking me to teach them about differentiation. And so I thought that's a good one because so many students are learning this and I think I can start a series on it. So I'm going to start from the most basic concepts and we're going to work upwards from that. So let's look at the most basic idea here, which is differentiation from first principles. Now this part, it can go very, very deep. And it may even require knowledge from other topics that you are not going to learn anytime soon, okay? Or you may not even learn at all. So I'm going to explain this really simply. If you are learning differentiation for the first time, this is all you need to know. I'll start with an example. Let's say we have the graph y equals to x squared, okay? So as you can see here, and this is the equation of the graph, okay? This y equals to x squared is the equation. When we differentiate this equation, y equals to x squared, we get dy by dx is equals to 2x. How do we get this? I'll explain later, okay? But this dy dx here equals to 2x is known as the gradient function. So before telling you how to get dy dx, I'm going to explain to you what dy dx is, what differentiation is. Okay, and it is the gradient function. Okay, so we say that dy dx, the differentiation of y, which is also the gradient function, tells us about the gradient. Basically, if you tell the gradient function what the x is, let's say x equals to 1, okay? So we are going to sub x equals to 1, then the dy by dx is going to give us 2, right? 2 times 1, because 2 times x, sub x equals to 1, you get 2 times 1, which is 2. What this means is, at x equals to 1, which is basically this point, isn't it? If we draw a tangent to the curve, which is basically the gradient of the graph at this point, something like this, okay, you probably have learned by this time how to draw graphs and how to draw tangents and find a gradient. Okay, you pick 2 points and you find the y2 minus y1 over x2 minus x1, the gradient. Yeah, and you will get a gradient of 2, right? So that's what this means. The gradient is going to be 2, and it's wonderful because we don't have to draw tangents, get 2 points and find y2 minus y1 over x2 minus x1 to get a gradient of 2. This gradient function basically tells us that just by subbing in x equals to 1. And that's a lot easier. Okay, or let's say we sub x is equals to negative half. So negative half is right here, okay? And we draw a tangent. That will be the gradient of the curve at this particular point, x equals to negative half. We will see that the dy dx is equals to 2 times of negative half, which is equals to negative 1. Yeah, so this gradient here is negative 1. So this is the first learning point, that once you differentiate, you get a gradient function. Then once you differentiate an equation, y equals to whatever it is, you get the gradient function. And if there's an x there, you sub in the x, you will get the gradient of the curve at that particular point. Next, we talk about the differentiation operator, d dx. Okay, so the d dx is the differentiation operator. So take note that this is an operator, it is not a number. Okay, so it operates like plus, minus, multiply, divide. These are all operators, like sine, cosine, tangent. These are all operators. Okay, so in the same way, d dx is an operator, it's not a number. We don't say sine plus tangent equals to, it doesn't make sense because they are not numbers, right? So same thing, d dx operates on a number or a function, but in itself there's no meaning of quantity in it. Alright, so a bit of notation here. If you differentiate y, that means you d dx the y, that will give us dy by dx. This is notation, okay? If you differentiate the y, you get dy dx. Or if you d dx the y, sometimes in some schools is written as y prime. If you differentiate x, that means you d dx differentiate with respect to x, the fx then you notate it as f prime x. Okay, the f prime, the prime here, tells you that the function fx has been differentiated once. Okay, and just one more time, d dx, what does it mean? It means differentiate with respect to x. Okay, differentiate with respect to x, d dx. It's not always going to be d dx. Sometimes you can get d dt, dd, whatever it is. Okay, depends on the question. Okay, but when we start, we always have d dx. And what this means is that the x is the variable that you are differentiating, and that's the thing that you are operating on. We'll see more of that in an example next. So next, I'm going to teach you how to do the differentiation. We start with this. If you have ax to the power of n and we're going to differentiate it with respect to x, d dx ax to the power of n. Then, this is the catchphrase that we're going to use. The catchphrase is basically a phrase that I mumble to myself when I'm doing differentiation. Okay, I do a lot of that when I was first learning. Now I don't do that anymore, but it's going to help you when you're starting out. Okay, so the catchphrase is bring down the power minus 1. Okay, so when you bring down power, it means that you multiply. Let's apply it to this ax to the power of n. The power here of x, okay, now we must be clear that we are bringing down the power of x, okay, not power of p, power of q, or power of 3, or whatever it is, because we are differentiating with respect to x. Can you see the dx here? Yeah, we are differentiating with respect to x, so we're going to bring down the power of x to the power of n. This n here is going to come down, and it becomes a multiply. Okay, n times ax to the power of n. Okay, so you see the n came down, right? And the power minus 1. So this power here, n, is going to get a minus 1. Yeah, that's basically how it is done. So if you differentiate ax to the power of n, power bring down, you get n here, times ax to the power of n minus 1, the power minus 1. So let's apply it to some examples here. We're going to differentiate the following with respect to x. Part A. Now, this is an expression given. So before we start, we have to write d dx 2x to the power of 4. So we're going to operate differentiation on 2x to the power of 4. The power here is 4. You bring it down to become a multiply. So you have 4 times 2x to the power of 4. And the power 4 minus 1. Simplify it. 4 times 2 is 8. X to the power of 4 minus 1 is 3. Right, easy. Part B. Again, we have an expression here, so I'm going to write d dx, and d dx of 5x squared minus 10. We will get, bring down the power. Now, if you fill up to it, you can straight away, you can see it's 5 times 2, right? So we have 10 here, 5 times 2 is 10. X to the power of 2 minus 1. If you fill up to it, 2 minus 1 is 1, but if it's x to the power of 1, we normally don't write, okay? So you're just going to leave it, 10x minus 10. Now 10 here is actually x to the power of 0, right? And when this 0 comes down, 0 times whatever it is 0. So there's nothing left here because it's multiplied with 0. So the result is just 10x. Part C. Now in part C, it's slightly different. In part C, what's given to us is slightly different. We have y equals, is an equation. So we have y equals 5x cubed minus 2x plus 12 minus 3 over x squared. Now this 3 over x squared, it's very awkward to do the mod. Now this 3 over x squared here, it's awkward to do the differentiation because it's not in index form. You can't see what the power is. To be accurate, it's actually 3x to the power of negative 2 because this x squared is in the denominator. So we always change the x in the denominators into x in the numerator, and we change the sign of power using laws of indices. So now if you differentiate y, this is important, If you differentiate y, this is dy dx. So power 3 times 5 is 15. X cubed minus 1 is x squared. Okay, if you don't feel comfortable doing that immediately, you can, still write proper working, 3 times 5 and then x to the power of 3 minus 1. You can write that, not a problem, okay? But eventually you're going to have to wear out of it, okay? So 3 times 5 is 15, x to the power of 3 minus 1 is 2. Minus 2x, now 2x is 2x to the power of 1, so 1 times 2 is 2, x to the power of 1 minus 1 is x to the power of 0. X to the power of 0 is 1, right? So 2 times 1 is 1, we just don't write this anymore. 12 here is a constant, so like what we did just now in part B, if you differentiate a constant, you get 0, remember that. So I'll just leave it. Next up, we have negative 3 times negative 2, that's plus 6. Then you have x to the power of negative 2 minus 1, which is negative 3. Okay, so in O-levels, if you are doing this from O-levels, then we normally present the answer in positive indices. So this is how it will be presented. Part D. Now again, we have y here. So after differentiation, it's going to be dy dx. But before that, we have to change this. Can you see this x here? Square root of x. Can you see this square root of x here? It's in third form. Again, you can't see the power, so it's awkward. It's difficult to differentiate. We will have to change it to x to the power of half before we differentiate, okay? Plus x to the power of 1/3. So dy by dx will then be half. Okay, we bring down this power. Then we have x to the power of half minus 1. Half minus 1 is negative half. Plus 1/3, bring it down. X to the power of 1/3 minus 1 is negative 2/3. Okay, so we can present it in positive indices. Now, the 2 here is the denominator, okay? But x to the power of half in the denominator is square root of x in the denominator. Plus, we have a 3 in the denominator as well. So this is 1 over 3. X to the power of 2/3. This is x squared, taking a cube root, okay? So this is the cube root of x squared. One common mistake I see in students is that in step 1, you have to change the square root of x in third form to index form. Some students change this to this, but in the same line, this x to the power of 1/3 is being differentiated already. That's not acceptable, okay? In one line, either it is all differentiated or it is all not differentiated. You can't have half-half, like half differentiated, half not differentiated. Okay, I call it half cooked. That's not acceptable. So we have x to the power of half plus x to the power of 1/3. I change them all in the same form, but yet the whole line is not differentiated yet. Then the next line I differentiate, we have dy dx, and then all this x to the power of half is differentiated, x to the power of 1/3 is differentiated. Okay, so please do the necessary changing first before you start the differentiation. That's the right way to do it. Okay, part E, we have fx. So this is a different notation again. Is equals to x cubed times x5 minus 3x4. Okay, so this requires you to do a bit of multiplication first. Okay, we multiply in, then our job will be a lot easier. Though we can of course do product rule, which is something that I'll teach later. Watch out for that video. But even though I know how to do product rule, I'll still multiply out because it's a lot easier. So again, I will not differentiate in this line, so I'll write fx, not f prime x. If I write f prime x, that means the line is differentiated. But as it is, I'm just going to multiply out, so I'll get x to the power of 8 minus 3x to the power of 7. Then f prime x, okay, now I differentiate. You have 8x to the power of 7, okay, power bring down, power 8 minus 1 is 7, minus, okay, the sign keeps, 7 times 3 is 21, x to the power of 7 minus 1, 6. Part F, fx is equals to 2x4 minus 3x plus 4 over square root of x. Whenever we see square root of x, we always change it to index form, so x to the power of half. Okay, but this one you can actually split it up into 3 terms so that the differentiation will be a lot easier. It's like saying 2/5 plus 1/5 is equals to 2 plus 1 over 5, right? So when we have this, we can actually reverse it and split into 2 terms as well, like what we are going to do here. So we have 2x4 over x to the power of half minus, okay, this is a minus here, 3x over x to the power of half plus 4 over x to the power of half. Okay, now we use laws of indices. We have 2x to the power of 4 minus half. Okay, minus 3x to the power of 1, this is x to the power of 1, minus half plus 4x to the power of negative half. Okay, so we simplify it further, we get so we simplify it further, we get 2x to the power of negative. Okay, it's best to write improper fractions. So I have 8 minus 1 is 7. 7 over 2 minus 3 3x to the power of negative half plus 4x to the power of negative half. Okay, that's it. So now we can start the differentiation, okay, after we get this form. So I'm just going to clear out and we get some space here. 2x to the power of negative 7 over 2 minus 3x to the power of negative half plus 4x to the power of negative half. Okay, and I'll clear the rest. Okay, so now I'm going to differentiate power bring down 2 times negative 7 over 2. The 2 cancels, you get a negative 7. X to the power of negative 7 over 2 minus 1, right, is already negative. Wait a minute, this is positive 7 over 2. Sorry. 4 minus half is positive 3.5, which is 7 over 2. Okay, so this is positive here. We have 7x, then you have the power 7 over 2 minus 1 is actually 5 over 2. It's normal to present your powers in improper fractions rather than mixed numbers. Okay, next, the negative half brings down negative times negative is positive. Half times 3 is 3 over 2. X to the power of negative half minus 1 is negative 3 over 2. Okay, and then finally 4 times negative half is negative 2, x to the power of negative okay, we do. So we break this down into 3 terms. You have 2x to the power of 4 over x to the power of half minus 3x over x to the power of half plus 4 over x to the power of half. Okay. Now we will use laws of indices. You have 2x to the power of 4 minus half minus 3 x to the power of 1, okay, this is x to the power of 1, right? Divide is minus, and then you get a half. Plus 4x to the power of negative half. Okay, this is x in the denominator, so you bring it up, you get a negative power. So we will simplify this to 2x to the power of 7 over 2 minus 3x to the power of half plus 4x to the power of negative half. Okay, so I'll clear out some space here and we will continue from there. You have 2x to the power of 7 over 2 minus 3x to the power of half plus 4x to the power of negative half. Alright, so now we can differentiate. And once we differentiate, we have to indicate clearly, okay? Now, many students just continue equal like this. No, not acceptable, because once differentiated, it's going to be f prime x. It's not equal anymore, okay? So I'll write here f prime x to indicate that differentiation is done already. 7 over 2 times 2 is 7. You have x to the power of 7 over 2 minus 1 is 5 over 2. Okay, then minus half times 3 is 3 over 2. X to the power of half minus 1 is negative half. And we have this one, 4 times negative half is negative 2, x to the power of negative 3 over 2. Okay, so we can take a final step to change this into set form if your school requires. And so we have 7, this is x to the power of 5, right? But then it's taking a square root, okay? Yeah, the denominator 2 is a square root, the numerator power 5 is just a regular power. Minus, this is a negative power, so it's in the denominator. Right now, we have 3 in the numerator and 2 in the denominator, right? And then we have x to the power of half, which is square root of x in the denominator. Minus 2 again is numerator. So you see, this negative power doesn't affect the 2. It only affects the x, okay? So you send the x to the denominator, cube of x, square root. Alright, that's it. So now, you try the questions and you tell me your answers. Let me have a look. And if you have questions, please put them in the comments so that I can maybe help you out a bit. Check out my next video for application of differentiation on tangents and normals in a graph. Alright, like and subscribe. See you next time.